In this tutorial, we want to look into the Numpy library. So I thought that in parallel with another course, the advanced topic in deep learning, I can create some content about um, basic of machine learning in Python. And in this video, I want to talk about only Numpy from beginner to advanced. So let's jump to it. I have created an empty project and I called it Numpy in Visual Studio Code. And if you haven't installed the plugin, you have to go and install Jupyter. And also you have to first install Python and then Jupyter. After you install these two, I'm assuming that you know how to write Python. And you can come here and create a file. I call it main, and the format is IPYNB, which is the format for Jupyter Notebook. Okay, so we have a cell here, and we can run a cell by clicking to this execute cell, or as the hint said, we can run the cell by Control-Alt-Enter. When my mouse hover on the bottom of the cell, show the code and markdown, and I can click on the code or I can create a markdown, and I can delete the cell. So this is similar to Jupyter Notebook that many people are writing in the browser, but I prefer Visual Studio Code because I have more flexibility. The first thing that we need to is import the library, and we can say import numpy as np. So the first thing that we can do with any library is finding the version. And the Jupyter Notebook always run the last line and print it. So if I have another line like here, I can have like A, and I just put the A like here. If I run, it only run the last line. So this will be run. If I want to run a bool line, I have to write like print. So it will write 1 because A was 1 and the version. So I just want to show you how to get your NumPy version. Let's open another cell. The next part is defining a matrix that all element is 0. We can write np.zeros, and it's bring us a hint that you need to write a shape, and shape is a tuple. So I can say I want a matrix, for example, with 5 row and 4 column. And let's see inside. You see this is 5 row, sorry, and 4 column. So the next things we want to do is we assign a variable to it. We call it z, and I want to say that for second row and first column, I want to set the value to 1 or anything else. So I can say I set for second row and first column. NumPy starts from 0 index. So the second row would be 1 and first column would be 0. And I want to set it to 1. And if I run this, I will not see anything because it is just an operation. So I can do like print z, or I can just type z here. And I see that I have the 1 in row number 2 and column 1. Similarly, I can say I want to have ones. It means I want to have a matrix with all of the values none, and this index I want to set it to 0. This is very similar to that, but instead of 0, I just create ones. I want to create a vector with value ranging from 0 to 10. So I can say like np arrange, and I set from 0 to 10. Also in documentation, it says that the stop is excluded. Yeah, the interval does not include this value, except in some cases where a step is not an integer, okay? So what can I do is I can reshape it, and it's ask me what shape you want it, and I can say I want to have like 5 row and 2 column. And if I do that, you see that it is reshaped, and it is 5 row and 2 column. But if I want to do something else, like I want to have 1 here, 2 here, and stuff like that. So one of the things I can do is like I create it in 2 by 5, and after I finish that, I just write the transpose of it. You see that 0, 1, 2, 3, 4, 5, 6, 7, 8. And T is here is like transpose. In NumPy, a transpose of a matrix by dot T. And there is NP dot transpose also. We can use that, but this is simpler. Okay. So one of the other things is, suppose we have a list like 0, 1, 0, 0, 2, 5, something like that. And I want to just get the non-zero value. So there is a function non-zero, and I can pass a to it. And it return me 1, 4, 5. It is index of when non-zero is happening. So if I want to get the exact value of that, so I can say this is the index non-zero is equal to np.nonzero. And after that, we can say a for index non-zero. Just show these to me. So the problem here is this is a list, and we are indexing a list like a NumPy. So this is one of the most popular issue that many beginners are facing with is they are assuming that this list should have a similar functionality and attributes like the NumPy list. One of the things we can do is we change this array A and we change it to the NumPy. We can say NP as array A. So this line will change the A to a NumPy list. So this is a Python list. This is a NumPy list. And after that, I can ask him to what is this index. So if I run this, it will return me 1, 2, 5. We can define an identity matrix. Identity matrix means that all of the diagonal elements are 1 and other elements are 0. So we have NPI, and usually identity matrix has same row and column. So that's why the second argument, which is number of column, is none, which means that if I just pass like 3 here, it will create a 3 by 3 identity matrix for me. Okay. Other matrix I can create is like create a random matrix. So there is a random function in NumPy, or random class, as we say. I can say np random, and after that I can define different random variables. All of these are different random variables. Like I can define rand n as a normal distribution. So I can define just rand. This is a uniform distribution. So for uniform distribution, I can pass 2 value like 3 and 6, something like that. And it will create matrix in size. Let me get the shape, type shape, and it just show me the shape. So I have created a matrix of uniform distribution, random variables with size 3 by 6. Other function I can use is like, I can use random. For random, I can pass size. I can say, oh, I want in size 3 by 6. We can get the minimum, maximum, median NumPy. So if I assign this random matrix to R, you can see there is a max, there is a mean, there is minimum, stuff like that. For example, I can write R.mean. It will show me the minimum value in matrix. But for example, if I want to calculate the minimum value in each column, let's make it 3 by 3. For example, calculate the mean value here, which is this one, calculate the mean value here, which is this one, and mean value, which is this one. So we can write np.mean, and I want to calculate the mean on R, but in which axis? So we can pass an axis 0. Why 0? Because I'm saying that get me something as a one row, which means that I want to calculate the minimum on each column. So if I do that, you see that I get 13, 18, and 24. Okay. If I do axis 1, so I'm saying that I want to get a matrix, I want to get the result in a column, which means that I'm applying to each row. So if I run this, you will see I will get this one from this row, this one from this row, and this one from the last row. We can do the same thing like with mean, with the median, with the max, with standard deviation. One of the other things we can do is, suppose that we have an image. An image can be a Numpy array. So suppose that we have image in size 10 by 10, for example. So this is my image. I create like using ones function, and size is 10 by 10. This is my image. And let's print it just to show you. And I want to set 0 on borders. We can say I have an image for all of the rows, but for column 0 and -1, set everything to 0, and do the same thing for all of the column, and 0 and -1 for rows. I set 0 on first row, on first column, on last column, and last row. But I haven't added 0. I want to add padding. So in this way, I'm not adding a pad. The NumPy has a function. Instead of doing that, I can say np.pad. And np.pad get an array, get my image, and it say, what is your padding width? And I say pad width is 1. And let's see what we get in output. You see, and if I just get the shape, just to show you. So it is 12 by 12. Why it is 12 by 12? Because 1 is added, 1 0 is added here, and 1 0 is added here. So 2 element is added on each row and also in each column. So the size would be that. But the previous method I use is not changing the size, but just put 0 in the border. So these two are different. In NumPy, we have something like inv. In NumPy, we have something called nan. And what are they? If I have a 0 and I multiply 0 with infinity, what I will get is nan. So mp.nan is equal to mp.nan. Are these two is equal? It is false. Suppose this interesting expression is np-info is bigger than np-nan. So an infinity is not bigger than np-nan. What about this? Again, is false. We cannot apply operation on nan. I can say like is infinity is bigger than 0. So it is true, but the nan doesn't work with operation. So if you have nan in our NumPy matrix or in our pandas data frame, we will have some issues and we have to take care about it. Let's do another example. Like I have np.nan minus np.nan. Is this result is 0? It's again nan, because nan is multiplied with anything or plus with anything or divided by anything. It is nan. It's not changing. Okay, another function in NumPy is the diag function. So we can use that for creating a matrix with defined diagonal value. For example, I can say I want a matrix that its diagonal value is like 3, 5, and 6. And it will create a 3 by 3 matrix. 3, 5, 6 is its diagonal value. Suppose we want to create this matrix. So we have like 5 by 5 matrix. So this is 5 and this is 5. And all of items here are 0. And all of items here are also 0. but I'm gonna have like 4, 3, 2, 1. For creating this, we need to see the other diagonal input. There is a k here. What is k? Let's see it. K, it means optional diagonal in question. The default is 0. Use k greater than 0 for the diagonals above the main diagonal and negative for diagonal below the main diagonal. So it means it would be easy. Let's say 4, 3, 2, 1, and k is -1. Is it working? 4, 3, 2, 1. Yeah, that's okay. So we could create it just by looking the other parameters of diagonal function. Let's go to another example. So we want to create a checkboard in size 8 by 8. So we can create a zeros matrix. So before that, I want to show you some example that's easier to run on a random variable. So if I write like, I want all of the rows, but for columns, I want from number 0 to number 4 in step 2. What will I get? So I want to get all of the rows. So I should get this column. I should get after that this column. And I will not get this column because I'm saying until number 4. Yeah. So I get this column and this column. So it is somehow like you remember we had NP arrange. So for indexing, we can use same thing. I can use like NP arrange with a step. Instead of here, I can write NP arrange and between 0 and 4 in step 2, it's exactly the same. See, exactly same things. But instead of writing that for indexing, I can just write 0 until 4 with step 2. Based on this, I want to create that checkboard. I want to delete this, and what can I do is I can say from number 1 to end. When I want to define end, I can like type -1, or I can just leave it. It will figure it out that I want until end. And with step 2 for rows, start from 0 and end until the end with step 2. And I want to set this to 1. Okay, let's just see what happens so far. If I print, we have this. We have 1, 1, 1. We need a 1 here, so we can repeat this pattern. This time, vice versa. It means this should come to the column. And let's see. So we have created a checkboard. Suppose we have an np.arrange, and it is start from 0, stop to 100. So we have an array here. I want to find out that if I change this matrix to like size 20 in 5, something like that, what is the index of element like 45, something like that. So I can do like unravel index, and it get what index are you thinking about, like number 46. If I have size in shape of 20 in 5, okay, it will give me it is number 9, row number 9, the first column. If I have something in size 20 in 5, number 46 is number 9 in 1. What does that mean? It means that if I reshape this in size 20 and 5, and it just say number 9 and 1, okay? And if I just print the number 9 and 1, this is number 46. If I have a matrix with this shape, the 46th element of that matrix is in this index. Remember that we had this, we created with indexing. There is another way to create that using np_tile. For example, for the chessboard, I want to repeat, it should be an NumPy array. So I want to repeat this pattern, okay? And I have repeat that 4 times, but I can also say repeat it by 4 by 4, which means 4 times in row and 4 times in column. So I have created the same matrix here and also same matrix with another method there. Okay, so NP tile can also be used for repeating. So let's back to other example. Let's suppose we have an random variable, random matrix. It is in size like 5 by 5. And I want to normalize this matrix. And I want to do the normalization, a z-score normalization. Z-score normalization means I subtract the average and divide by the standard deviation. So I can do like, it can define z score, it get a mat, and I can say mat minus np dot mean, and it get the mat divided by np dot std on the mat. I didn't need these parentheses. I need a parenthesis here. Okay, and I say like print z score of the R here. What I will get, this is a normalized version of the mat. So the mat is normalized. So we have a 5 by 4 matrix here as R1. And suppose we have another matrix like 4 by 10. And I want to do a matrix multiplication like R1 matrix multiplied by R2. And this is R2. I can do like R2. We can see it will create a size 5 by 10 and just print the output, that shape. So in Python, output that shape. In Python, this operator is doing the matrix multiplication. Besides of that, we can also use, instead of this, we can use also np dot dot. np dot dot is dot product of 2 arrays. If A and B are one dimensional array, it is inner product. But if both are 2D array, it is a matrix multiplication. But using matmul or A and B is preferred. So it is more optimized. So we can use dot, we can use matmul. All of them will give you same result, but some of them has better performance. But this is not defined in Python version less than 3.5, I guess. So let's do other things. So if I have this, I want to say like every value between 3 and 6 should be 0. So we have an array like this one. I set it as condition 1. And we have another array like condition 2, which says everything is bigger than 3. And these two conditions can be and, I guess, condition 1 and condition 2. What is that? It said the truth valuable array more than one element is ambiguous. We want to do some and on 2 array, but we cannot do it. One of the things we can do is use the np dot logical and we can do logical and on 2 different array and 2 different conditions. Okay, when I do this, it will get me the correct one, and I can apply it as an index. When we have an index like false, 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 it means I don't want to select this. So if it just select true value. So it will select 3, 4, 5, 6. But I said I want to set these value to 0. Okay. And if I now print the A, it would be this, as I wished. There are also logical or logical not XOR. If I want to do something reverse, like these value, I want to set them to 0, but I want to keep this. One of the thing I can do is like np.logicalNot. Okay. And it just returned this value for. So be careful that some things like and, something like not, stuff like that is just applying on one variable. It's not applying on the list or NumPy list. Okay, let's go to another example. Suppose we have again this value. We can say this, it means that every item should be in power of 2. What other thing I can define is, what if I say I divided by a divided by a. So it would be all of things is 1, but 0 divided by 0 is nan. And if I now do like np.min on a by a, something like that, would be nan, because nan, as I showed you, is just ruining everything. What is this operation? So this operation is same as a divided by a, but it cares about nans and set the nan to 0. So the reason that this is set to 0 is because this is used for flooring division. Means after division, we flooring the result, which means you see here, this is a int 32, and all of the value here should be in range of 32. So if you have some floating points, it just round it, floor it. So that depends on you want to get the integer value or you want to get the floating points. Well, suppose we have an array and that array has just a nan. I can change the type as type. I can say this is the type. I want to set the type to int32, and for int32 I can use np.int32. Okay, see, np nan now has some value, and that value is something, it's just a random variable. I don't know, it's coming from the memory. If I set, instead of int32, I set it to the float, I again get the nan. So the nan type should be like float. So if I write type np.nan is float, because nan is float. Suppose we have this, and I want to find out, you remember that we had this operation for finding out the position of an index, but I can write np where a is bigger than 3. Okay, if I do this, it gives me a tuple. You can see that this is a NumPy array finding the position for us. So I can say get the position, and it's get me the position. We can also do if and else statement. So I can say if it is bigger than 3, calculate the power of 2 of a, otherwise just a. We can do something like that. So if it is bigger than 3, we calculate power of 2, otherwise just return them. For making it more visible, maybe I can do it reverse. So these values are in power of 2, but these are exactly the same. So where has some condition, we can write it as an if and else. Let's do another example about sets. So one of the variables start from 0 to 10, and one of them start from like 5 to 15. Okay, and this is a and b, and I want to find the intersection. So I can type intersect one dimensional and a and b. So these values are intersected. Okay, let's do something else, like calculating this, and it return nan. But if I do emath and the sqrt, it will return ij. So the sqrt function does not include the complex values. So we can use emath or we can use sqrt based on the usage, but these two are not equal. Okay, let's jump to another example. We can work with date, time, and time in NumPy. And for example, we can say DateTime 64, np.datetime 64. And we can like say DateTime 64 for today, Okay, and what we can do is like there is an NP time delta 64. We can like remove 1 day from today and show it. You can see it was 4 September, sorry, 4 October, and now we are in 3 October. And we can add or remove day or stuff like that. We can use np arrange, and instead of a start and a stop by number, I can use the date. Like I can say 2021. I want to get from September to, this is the end. The end is 2021 October, and I need to pass a D type. The D type in here, I want to say I want to have a date, so it can be a DateTime 64, and I want a day. DateTime 64 and D in bracket means the format is just day. And if I run this should be uppercase. And we get all of the day in September. Okay, let's go to another example. Suppose we have a Z, and Z is the np.random. This one I want to use uniform random. Uniform random, we need a lower and higher in size. And you can say lower is 0, higher is 0. It means that between 0 and 10, the uniform distribution. And I want to have size 10. I want to extract the integer part of the variable. I can do something like double slash operator to the floating division. So if I do the floating division by 1, I'm getting the integer part of the random array. Instead of doing that, I can say as type np.int 32. Okay, this is another example. Every time I'm run this is generating new random variable. That's why it's not similar to previous. I can use np.floor, which is flooring. We have np.sale. It is rounding to the sale, but the flooring is rounding to floor. Okay, another example I want to show you that suppose we have np.zeros and the size is like 5 by 5. What if I multiply this matrix with a vector, arrange, and let's make it once to have something when we multiply the matrix. What we'll get is this. I mean, we had a one matrix and we multiply it with 0 to 4. But you see that every row of that matrix is element-wise product by the vector that we have. Instead of multiply, if I add these two matrix and vector, so I will see the same result because this is a matrix with size 1 by 5, and this is a matrix with size 5 by 5. So if I like select 4, I will get an error because the size is not feed and cannot do the row operation. So that's why I selected 5. And you see that it is Rawwise. Okay, let's go to another example. We know that in Jupyter, we can use time it for a cell, or we can use only 1% sign for one line. But I want to calculate it for cell. And I can calculate the time of running a cell. And in this case, I want to create a vector in size of 1000 between 0 and 999. And I want to do the summation. If I run this, it will show me how much time it would get to run this. It would take about 5 microseconds. So I put time it again, but instead of applying np sum, I can use reduce function. So I can say np dot add dot reduce, and same things I apply here. So the add reduce is taking less time, like 2.5. The reason is that when we apply np.sum, ultimately it will call
add.reduce, but there are some overhead. Um, and overhead is handling some arguments, some dispatching, and that's why it's take a little time to calculate the sum. In NumPy, we can make an array immutable or read only. And suppose we have something like this random variable. For this, I have something like flags, and flags can be writable as false. So if I do that, and if I do like, I want to change the first index of the variable, print z, instead of random variable, maybe having a zeros is better, 10 by 10. And I want to set the first one is to 1. What will I get is argument destination is read only, which means that we cannot apply anything to it, which is sometimes good. Two functions exist that sometimes are very important, argmin and argmax. So suppose we have a random variable like this one. I want to set the maximum value to 100. You can see this range between 0 and 10, and I can say z for the argmax. I want to set it to 100, and after that I want to print z. So it means that the argument of the maximum value created by random variable should set to be 100. You can see if I run it again, it would be another variable because it's generating different value. So argmax and also argmin, the argmin are two important function. Instead of this, we can also do np.argmax and pass the z again. Both are doing the same. So what's other usage of the argmax and argmin? So sometimes we need to find the nearest or closest value in a vector by a given scalar. So suppose that we have like a z, which is arranged in size 100, and we create a random variable, like we call it point. And random variable is based on uniform random between 0 and 100. So the point is just a random variable, just one variable. I want to find the closest point inside the z to the point. So I can say every time I can calculate z minus point. And if I apply the np.argmin, I am calculating the position of the minimum value inside the z to the point. So I can set it as an index, and I can, just for showing you, I can print what was the point. I use F here. What was the point? And we say is close to, and what was the index? Okay. If I do this, 0.89 is closer to 0, which is not right. So when we calculate this, we are doing argmin, and so we need absolute value. So I can use np.abs as a absolute value. And if I do it again, so it's say 88 is closer to 88. Again, 16 is closer to number 16, which is right. Yeah. Okay, let's go to another example. Suppose we have np dot, let me use this. Suppose we have np.random, and I want to shape like 5 by 5. Okay, this is a z, and I want to do enumeration in for loop. We know that in Python we can use like index value in enumerate and like in the z, but here this is a numpy, and we want to have like the index of that. Instead of enumerate in Python, we can use nd enumerate. And I want to just show you that if I print index, let me do it like this. If I print index and value, what will I get is, you can see index is 0, 0. This is a tuple, and it's showing all of the index. So suppose we have this random variable, and what if I call np min and I calculate the mean? I want to have the result on one column. So it means that we are applying the average on each row. Okay, there is another parameter we can pass is keep dimension. I can pass the keep dimension is true. So you can see that sometimes maybe it's difficult to figure it out that how we calculate the mean. And in this way, if we keep the dimension and if we like do subtraction, because we keep the dimension, it's subtracting each row from its average. So we can say print z here. And after calculating the average, I also want to have np min, and we can also print the result. And I think it's good to have min. I just want to show you that how things works. So it show me that 58 should be reduced by all of these row. You can see here, 58 is reduced, and is reduced. And if I remove the keep dimension, what will I get is 28 is reduced from this, and 28 is reduced from this, which means that the Python thinks that it should repeat the matrix based on what is remained. And if I keep the dimension to true, so it will repeat the matrix based on the column repeating, and if it will do the right things for me. So be careful about when you do subtraction and multiplication, and try to keep the dimension based on what you intend to do.
So far, we have explained some example about elementary and intermediate level of using NumPy. And I feel we can go to some advanced example. Okay, let's assume that we have np.ones in size of 10. And let's create another variable. I call it like index, something like that. And it is np.random. And there is a rand int I can create in integer random. And it is from 0 to length of the z. We want to get like 20 example of this index. So just want to show you how indexes look like. So we have integer random variables, and they can be repeated because this is only from 0 to 9, and we want 20 of them. I want to write a function or a line of code that add 1 to each value of vector z that they are indexed by this value. So for example, I can say z index is everything is inside is +1, and I can print it. But the problem is when we do this, it applies a unique operator when we are indexing. So if you want to add 1 to each index exist in the index vector, there is a NumPy method called np-add, and with np-add we can say np-add at, and it get the vector and the index. Okay. What else we can pass to it is the b, and b is our indices plus equal b, except the results are accumulated for elements. So for this purpose, we can pass 1, which means that it is same as doing this, but this index is not unique. So we can comment this and run this line, if I print C, I will see that the 1 is added according to how many times it's repeated in the index. So suppose we have a function, it's getting 2 variable, can be list, can be numpy array, anything. It will return a plus b. Okay, so I can call this function like I have these 2 lists, a and b. And if I call a and b, when we add these, they are just concatenated because this is just a Python list. If I do something like np.vectorize and add, so I can call it vec add. I can run it again, but this time it's adding parameters. What happened is we are vectorizing this, or we are saying that each variable here is a numpy vector. So it's not working like a Python list. It's working with the numpy functionality. Other things that we can pass to this vectorize function is we can exclude a specific variable. So maybe there is some example here I can show you. Yeah, so we can exclude a variable, like I can say excluded, and I exclude like variable a. And if I say a is a and b is b, and I just run it, so we exclude that everything here is like a will be excluded. If I just exclude one of them and run it, I will have issue because cannot concatenate a list of Python with another list, which is NumPy. So it cannot concatenate these together. It's not improving the performance. In documentation, it also said that it's not working on the performance, it's just vectorizing it for us, making it more easier to work with the NumPy. Suppose that we have a random variable and its size 5 by 5 by 3, and another random variable, but with size of 5 by 5. And we want to have a multiply these two variables together. If I get the shape, like you can see here, it is 5 by 5. But what if I say that all of the elements here, all of the elements here in np new axis, and I show the shape of it. So it would be 5 by 5 of 1. So one of the way to add one dimension, we can type np.new axis. So in this way, I can like write multiplication between a and b. Okay, but if I don't have this and I just multiply it, give me the value error because shape are not same. So this is one of the way. Instead of having this, I can just type none. Okay, it's works same. The reason is the np axis is similar to none. So this is just something defined for readability. That what is the result shape? Okay, it would be 5 by 5 by 3. Why? Because it's repeating this matrix in this 3 dimension, as we discussed it before about multiplications or other operations. So if I have more than one dimension here and I don't want to talk about them, I can just put 3 dot here. It means that everything is here, just keep it and do the same. So maybe I have like a tensor with more than 2 or 3 dimension. I don't need to write every time something like that, and I can just put just 3 dot working same. So NP has also some linear algebra functions. Suppose we have a matrix like in uniform random distribution between 0 and 10 values and in size of 10 by 10. And this is our random matrix. And what we want to do is detecting the rank of the matrix. For detecting the rank, we can do the SVD. For applying the SVD, we have np.linear algorithm, and we have a SVD. And we can apply SVD, and you can see that by applying SVD, you will have 3 things return: U, S, and VH. So I can get U, S, and V, okay? We know that for finding a rank, the singular value that are not 0 we can count them, and this is the rank of a matrix. So we can count the singular value, and we know the S is just a diagonal, so I can just sum S. One of the easiest ways is to say, give me S that are bigger than 10 in power of minus 10. And it is a Boolean. So counting on the Boolean array is counting number of true. So let me give you an example. So if I do something like np sum and I have false, true, false, okay, and this is a list. And if I calculate it, this is 1 because there is only one true. If I have 2 true here, so it would be 2. Okay, so when I do this, I'm exactly counting the number of non-zero values. So it is 10. You can find the most frequent value. So suppose that we have np.random.randint, and for randint we say between 0 and 50, I want to like 100 numbers, or make it a smaller, like between 0 and 5, I want 10 numbers. And this is my random vector. So there is no statistical mode in Python. So for finding the most frequent value, we can find the bin count, and we find the bin count from this one. And after that, we can find the argmax. What does that mean? Let's I do it one by one. When I do the bin count, it will show me that which value is repeated how many times. And when I do the argmax on it, it will show me which one is repeated more than other. So in this case, we are counting the most frequent value, which is number 1. So if I just print R to show you how it is, so you see 0 is repeated thrice, and it's repeated more than any other. And you see again, 0 is repeated 4 times, and we are calculating the most repeated item. Suppose we have a large vector. I want to create random, and the size is like 1 in 1,000, something like that, or maybe more than that. And what we want to do is calculate the time it when I want to calculate the power of 3 of this matrix or vector. One of the way is using np power. So I can say np power 3. Another way I can use is I only can say x in power 3. But another way is using the einsum. So we are supposing that we are getting I, and what we want to do is calculating the I. So it's like multiplying these items 3 times. But what input we need to pass is x, as each I is passing to the system. So if I run this, I just change this to be just like a vector, doesn't have any other axis. So if I run this, it takes about same for running these 2 operations. Instead of that, I can maybe try these 2 to show you another approach. So the first one, 245 seconds. The second one that it is 6 microsecond. And the last one is the einsum, and the operation took 9. So the best way to calculating the power is just the multiplication. So, and finally, just introducing some other function that NumPy has, like I introduced like min, and there are something like nan-min and nan-median, stuff like that, and they are ignoring the nan value. You remember that nan value has issues with operations. And if we do this, like applying nan-min, and there is a vector in NP as array, and that vector has like NP nan and 0 and 1. If I apply this, so it's just ignore the nan. Suppose it's not here. But if I apply min, so it will return nan. Another thing that we can do with the NumPy is we can apply FFT and IFFT, and it can be two-dimensional. Can apply FFT shift. This is signal processing parts. There are some other parts of NumPy that needs to look into the documentation for learning, and I recommend you read the documentation truly. We try to cover every aspect of NumPy that you need to work during doing a machine learning project. Thank you very much. Please leave comment and let me know about the content and give me some suggestion if you have some. Have a good day.